Hello, welcome. This is Austin from Tclassified.com. Today we're going to be looking at electrolysis. Electrolysis is a concept in both physics and chemistry. Today we're going to be looking at it critically and actually what is electrolysis? What brings about electrolysis? Electrolysis, when an electric current passes through a chemical solution, the composition of the chemical substances takes place. The process by which this occurs is known as electrolysis. So electrolysis is actually the decomposition of the chemical substances inside a chemical solution that is caused by the passage of electric current. So you have a solution, then you pass electric current inside it. There is decomposition. You see movement of cations and anions. So that is electrolysis. Now, what is an electrolyte? What is an electrolyte? An electrolyte is a substance either in solution or in molten state that conducts electricity or electric current and undergoes decomposition. So that very solution that decomposes when electric current passes through it is known as electrolyte. So this solution it can be in also in molten form. Now, what are electrodes? Electrodes are two poles or plates dipped in an electrolyte and at which current enters and leaves the electrolyte. So those poles through which current enters and leaves the electrolyte is known as electrode. The pole through which the current enters the electrolyte is the positive electrode called anode. So that very point in source where the electricity or the electric current enters the electrolyte is known as the anode, while the one through which the electric current leaves the electrolyte is the negative electrode called the cathode. So basically in electrolysis we have two poles or two electrodes. We have the anode and the cathode. The anode is from where the electric current enters the electrolyte, whereas the cathode is from where the electric current leaves the electrolyte. Now, very important aspect of electrolysis is the Faradays laws of electrolysis, and that is what we're going to be looking at in this slide. And what does this say? Faraday's first law of electrolysis states that the mass m of deposition at the electrode during electrolysis, or the mass deposited at the electrode during electrolysis, is directly proportional to the quantity of electricity passing through the electrolyte. Very important. So the mass deposited, or the mass of deposition. When electrolysis is happening, some mass are being deposited at the electrode. So this mass that is being deposited, the quantity, it's actually directly proportional to the quantity of electricity that you are passing through this very electrolyte. So that is what the first law of electrolysis is talking about, that the mass m of deposition at the electrode during electrolysis is directly proportional to the quantity of electricity Q passing through the electrolyte. Now let's look at the second law. The second law of electrolysis states that if the same quantity of electricity is passed through different electrolytes, the ratio of the masses deposited at the electrodes is equal to the ratio of their chemical equivalent. So you're going to find out that these very two laws that I just stated, the first law of electrolysis and the second law of electrolysis, we are going to be using them in solving calculations. So it's very important that you note these two laws. First is the first law of Faraday, the Faraday's first law of electrolysis, which states that the mass of deposition at the electrode during the electrolysis is directly proportional to the quantity of electricity Q passing through the electrolyte. So you can say that M varies directly as Q. And you can introduce a constant and now say M is equal to KQ, where K is the constant. Then for the second law, that states that if the same quantity of electricity is passing through different electrolytes, the ratio of the masses deposited at the electrodes is equal. So M1 over M2 is equal to the ratio of their chemical equivalent. So those are the two major laws of electrolysis, which we are going to be taking critical look at. Now, what are the applications of electrolysis? What do we use electrolysis for? Now that we've known what electrolysis is, that is actually the decomposition of solutions when electricity is passed through them, and that in every electrolysis setup there is always an anode through where the electric current enters the solution or the electrolyte, and there is always a cathode through where the electric current leaves. So in every electrolysis setup there must be two electrodes, anode and cathode. So what are the applications of electrolysis? Electrolysis is applied in electroplating, a process by which a metal is coated by gradual deposition of another metallic element on it. Example, silver plating of iron, in which the iron is made the anode and the silver compound the cathode. So there is always deposition at this anode. There is always deposition at this anode. You see the iron now will now be plated. On top of it, you're going to coat silver, so that when somebody sees the iron, it will be like a silver, it will be glittering. So if you want to have such coating or deposition, in electrolysis we say there is always deposition, and this deposition is varies directly or is proportional to the amount of electricity that is passing through the electrolysis. So if you want to have such deposition, you have plenty iron and you want it to look like silver so that people will buy the material. So you have to use electrolysis to do electroplating, to plate on the iron, so to plate silver on the iron so that it will be looking like a silver. So electroplating is simply a process by which a metal is coated by gradual deposition of another metallic element on it. Example is coating iron with silver, where the iron is at the anode and the silver is at the cathode. That's the arrangement that you make in the electrolysis setup, so that the silver can be coated on top of the iron. Number two use of electrolysis is in extraction of metals. So JAM or WAEC or any exam is going to ask you which of the following is not a use of electrolysis. You should be able to find out that electroplating is one of the uses, extraction of metals is one of the uses of electrolysis, purification of metals such as copper is also one of the uses of electrolysis. Now we also have increasing the capacitance of an electrolytic capacitor. It's very, very important. That's one of the ways of increasing the capacitance of electrolytic capacitor, by doing electrolysis, by forming the required dielectric material like aluminum oxide during the electrolysis of ammonium borate in between aluminum sheets acting as electrodes. So you can increase the capacitance by actually having electrolysis happen. So this happens by what? Forming the required dielectric material like aluminum oxide during the electrolysis of aluminum borate in between aluminum sheets acting as electrodes. Now, calibration of an ammeter. You can actually use electrolysis in the calibration of an ammeter. And lastly, the calibration is achieved by determining the amount of electric required to deposit certain mass of substance at the electrode this time around, using the relation M is equal to Z LT. You see, mass is directly proportional to the quantity of electricity. So you can break it down into current and time. I say that M is equal to Z IT. So that is where we're going to be stopping in electrolysis for today. In subsequent classes, we're going to look more into these and other things. Please, if you like this video, hit the subscribe button. If you have any questions concerning these and other things that we've been teaching you, please drop it on the comment section for me. If you need information about us, how to contact us, and every other thing, please check out the description part of the video to get to all our other videos. We release videos every morning from about 8 o'clock to 10 o'clock in the morning. So always hook up with us so that you can always get videos that will help you to prepare for your JAM, prepare for your WAEC, prepare for your GCE, and as well learn things about programming, software development. Once again, thank you. Hit the subscribe button immediately. Thank you. God bless you.